Very good morning to one and all. My name is P. Rajita, lecturer in Electronics and Communication, Government Polytechnic, Maunda. So I am dealing third semester subject Network Analysis. Now I am going to discuss the topic source transformation, means conversion of voltage source to current source and conversion of current source to voltage source. What is source transformation? Source transformation methods are used for circuit simplification to modify the complex circuits by transforming independent current sources into independent voltage sources and vice versa. Means the independent voltage sources into independent current sources. Now I am reviewing of energy sources. So already we discussed about this energy sources. The two types of energy sources are voltage source and current source. So what is an ideal voltage source? A voltage source is two-terminal device whose voltage at any instant of time is constant and is independent of current drawn from it. Such a voltage source is called an ideal voltage source and have zero internal resistance. Practically, an ideal voltage source cannot be obtained. In laboratories also, we are having a regulator power supplies and audio oscillators. All are having internal impedance. See the symbols of voltage sources. The DC voltage source and AC voltage source. Symbol is given and the voltage and current characteristics of the voltage source and also here it is shown. And here the voltage current is increasing, the voltage is constant for changing in current. This is the voltage and current characteristics of the ideal voltage source. So practical voltage source. The source having some amount of internal impedance is known as practical voltage source. Due to this internal resistance, the voltage drop takes place and it causes the terminal voltage is reducing. The smaller the internal resistance of a voltage source, the more closer to an ideal source. If a larger internal resistance is there, then the terminal voltage is totally dropped. So the example of voltage sources is batteries and alternators. The terminal voltage Vt depends upon the source current, that is Vt is equal to Vs minus Is into R, where Vt is the terminal voltage, Vs is the source voltage, Is is the source current and R is the internal resistance of the energy source, voltage source. Here the figure is shown in this an ideal voltage source, a voltage source in series with internal resistance R. And here the voltage and current characteristics are shown here. The current is going on increasing, the voltage is dropping here because there is a voltage drop in R, internal resistance R, so that the terminal voltage is going on drop. So now I am going to discuss about ideal current source. The current sources are further categorized as ideal and practical current sources. An ideal current source is two-terminal circuit element which supplies the same current to any load resistance connected across its terminals. It is important to keep in mind that the current supplied by the current source is independent of voltage source terminals. It has infinite resistance. See here, this is the AC current source and DC current source, and the voltage and current characteristics of the ideal current source. Here, the current is constant by varying the voltage. Okay? Here, the voltage across the resistance is going on varying. Then the current is, that is, constant, supplied by the source is constant. So practical current source. A practical current source is represented as an ideal current source is connected with a resistance in parallel. In this, the magnitude of current falls as the voltage across its terminal increases. The terminal current is given by IT is equal to IS minus VS by R, where IT is the terminal current, IS is the source current, and Vs is the voltage, source voltage by R, where R is the internal resistance of ideal current source. See here the figure, the current source is in parallel with the resistance, and the current, whatever the ideal source, the current is constant by increasing this voltage, but in practical current source, the current is decreasing by increasing this voltage. So here, if it is nearer to ideal or a good current source, means it should have high internal impedance. For voltage source, the internal impedance should be 0 or nearer to 0. And for good current source, the internal impedance must be infinite or nearer to infinite, means it is very high internal impedance should have. Now the voltage source transformation. So for already we talking about that, there is a simplification of complex circuits. We have to transform the voltage sources to current sources. In some applications, the current sources into voltage source. Now I am going to discuss about the source transformation. We will first go over the voltage source transformation. The transformation of circuit with a voltage source to the equivalent circuit with current source. So this is possible by making that Ohm's law. Let's take the circuit below, which has a voltage source as its power source. See here, there is a voltage source. Voltage is in series with resistance. This may be converted into a current source, I in parallel with S resistance. So using source transformation, we can transform this above circuit with voltage power source and a resistor R in series into the equivalent circuit with current source with a resistor in parallel is shown below. We transform a voltage source into a current source by using Ohm's law. A voltage source can be changed into a current source by using Ohm's law formula, that is I is equal to V by R. See here, the I is equal to here V by R and the current source is in parallel with resistance. So conversion of voltage source to current source. Let's do an actual example to demonstrate the mathematics of Ohm's law using the circuit shown below. See here, a 10 volts voltage source is in series with 2 ohms resistance. Here we have a circuit with voltage source of 10 ohms with a resistor in series to 2 ohm resistor. See here. To calculate the equivalent current source, we have to calculate by using the formula, the current is equal to V by R. Then I is equal to 10 ohms by 2 ohms, that is 5 volts. So that how the equivalent circuit will be? The equivalent circuit will be a 5 ohms current source is in parallel with 2 ohms resistor. See, the resistor value, as with all source transformations, stays the same. The only thing that changes is now it is in from series to becomes parallel. So all of you remember that always a resistance is in series with voltage source and the resistance is in parallel with the current source. And while transforming from voltage source to the current source, we are changing this only current, but the resistance value is same in voltage source and in current source. But in voltage source, the resistance is in series, and in current source, the resistance is in parallel. So current source transformation. Now we will go for current source transformation. The transformation of circuit with a current source to the equivalent circuit with a voltage source. In order to get a visual example of this, let us take the circuit below which has a current source as its power source. See here, the current I is, source I is in parallel with a resistance R. And now this has to be replaced with a voltage source, and with V is in series with a resistance R. Here in these two current source and voltage source, the resistance is same, but the resistance is in parallel with current source and the same resistance is in series with the voltage source. But the voltage is equal to same Ohm's law formula, V is equal to IR. So here the current and resistance is multiplied and whatever the voltage is given, that voltage is in series with the resistance. So using source transformation, we can change or transform this above circuit with a current power source and a resistance R in parallel into the equivalent circuit with a voltage source with a resistor R in series. We transform a current source into a voltage source by using Ohm's law. A voltage source can be changed into a current source by using Ohm's law formula, V is equal to IR. So, for example, let us take an example to demonstrate the mathematics of Ohm's law. Using this circuit, here a 2 amps current source is in parallel with 3 ohms. Now we want to transform this current source into a voltage source. So how much it is? The voltage V is equal to I into R. So here V is equal to 2 into 3, that is 6 volts is in series with 3 ohm resistor. See here, the current in source is in parallel with R and voltage source is in series with R. The resistance is same, there is no change, but except that in current source it is parallel, with the voltage source it is series. But here the voltage V is equal to I into R. Here we have a circuit with a current source of 2 amps with a resistor in parallel of 3 ohms. Now by calculating that V is equal to IR, we are getting a 6 volts in series with the resistor 3 ohms. So we are taking another example, that is conversion of current to a voltage source. Here we are taking a 20 amps current source is in parallel with 10 ohm resistance and its terminal impedance is 10 ohms. Now we are converting that current source into a voltage source. So how it is possible? The 20 ohms internal impedance is 10 ohms. 20 amps current source, 10 ohms is the internal impedance. That can be replaced by a voltage source, that is V is equal to I into R. That is 20 amps into 10 ohms, that is 200 volts, is in series with 10 ohms, and a terminal impedance is 10 ohms. So now I am going to take another example. All of you understood this? Now I am taking another example, that is an equivalent current source of voltage for a voltage source in series with 3 ohms resistance. See here, 6 volts voltage source is in 3 ohms resistance. Now I am going to convert into the current source. What is the current? I is equal to V by R. V is 6 volts, R is 3 ohms. Now the current is 2 amps. Now it is converted as 2 amps in parallel with 3 ohm resistance. And so, is it correct or not? We want to check this. So, how to check this problem? So, here 6 volts voltage source is in series with 3 ohms internal impedance. This is connected by a load 9 ohms resistance. So, what is the current flowing in the 9 ohms resistance? And now, by cross checking that, by changing this voltage source into the current source, then what is the current flowing through the same 9 ohms resistance? If the same current is flowing, this transformation holds good. Now I am going to check this. See here, a 6 volts current voltage source is in series with 3 ohms resistance, and 9 ohms is the terminal resistance. Now let us, 9 ohms is connected terminals, and current supplied to this 9 ohm resistor is I is equal to total voltage. So what is the voltage? Yes, 6 divided by 3 plus 9 ohms. So here the current flowing through this 9 ohm resistor is only 0.5 amps. This is the first case in voltage. So 0.5 amps is flowing through the 9 ohms resistor in voltage source is in series with 3 ohms. So in the same thing, after source transformation, the same current has to be flowed in 9 ohm resistor. Now I am going to check this. See here, the voltage across the load is 4.5 volts. See in a figure, the total resistance is 3 ohms is in parallel with 9 ohms. So 3 ohms in parallel with 9 ohms, the total equivalent resistance is 2.25 ohms. Voltage across 3 ohms is 2 into 2.25 ohms, that is 4.5. Current to 3 ohm resistor is 4.5 by 3, that is 1.5 amps. Now current supplied to the load is 2 amps minus 1.5, that is equal to 0.5 amps. See, in a first figure, there is a voltage source. From that also the current flowing through 9 ohm resistor is 0.5. And in a second figure, in a current source, the same 0.5 amps is current flowing through the same 9 ohm resistor, that is load resistor. So now we are going to take another example. See here, obtain an equivalent voltage source for this current source. Here a 10 amps voltage current source is in parallel with 20 ohms resistor, and this, for converting this voltage same by applying Ohm's law, the 10 amps into 20 ohms is equal to 200 ohms. So it becomes a current source. So it becomes a voltage source. This 200 volts in series with 20 ohms. Hence the equivalent voltage source is shown above. So now we are taking another example. Here, what is that? There is a reduce the network of a single current source and calculate the current through it. So in this circuit, what are there? There is a voltage source, there is a current source, and a two resistors, 12 ohms and 16 ohms. Now, problem is it has to be convert this total network into a single current source. So now what we have to do, this voltage source 24 volts is in series with 6 ohms, that must be converted into a single current source. So here 24 volts is in series with 6 ohm resistance. We can replace this with a current source. So here 24 by 6 is equal to, there is a current, that is I1. I1 is equal to 24 by 6, that is 4 amps. Now it is replaced by 24 volts voltage source by 4 amps current source is in parallel with 6 ohms. So there is a two current sources, that is 4 amps current source and 6 amps current source, and 3 resistors are in parallel, that is 6 ohms, 12 ohms and 16 ohms. Then this can be replaced by a single current source, that is 4 amps plus 6 amps, both are in parallel now. So these two currents can be added and both are in the same direction. See here, it is negative is downward and positive is the upwards. So both are in the same direction, so that the total current I is equal to I1 plus I2, that is 4 plus 6 is equal to 10 amps now. And the equivalent impedance is R is equal to 6 into 12 ohms divided by 6 plus 12 ohms, that is equal to 4 ohms. So current through RL is 2 amps. See here, now what is happening here? There is a 10 amps current source is in parallel with 4 ohms, that is the current source, and this current source is connected with a terminated impedance 16 ohms. Now the current through the RL is equal to 4 into 10 divided by 16 plus 4, 20. So that is equal to 2 amps. Again I am repeating this. See, current through RL is equal to the current I into 4 ohms divided by 20 ohms, that is 4 plus 16. So how much? It is 10 into 4 divided by 4 plus 16, that is equal to 2 amps. So the total circuit is replaced by single current source with 10 amps in parallel with 4 ohms, and the terminal impedance is 16 ohms, and the current flowing through the 16 ohms is 2 amps. See, I am giving two problems for homework. Here, the voltage, find the voltage across 100 ohm resistor using source transformation technique. In this, we can take in two methods also. Here, 250 volts, I am giving a hint how to do this problem. In this, a voltage source 250 volts is in series with 25 ohms, and 8 amps current source is in parallel with 20 ohms, and the terminal impedance is 100 ohms here. So that if we can transform this voltage source into a current source, how much you are getting? A 10 amps current source is in parallel with 25 amps and 8 amps current source is in parallel with 20 ohms. But the directions of both are different here. It is 10 amps is upwarding, 8 amps is downward. So the net current is only 2 amps is in parallel with 25 into 20 divided by 25 plus 20. So the equivalent resistance has to be obtained. So 2 amps is in parallel with the resistance and it is terminal impedance is 100 ohms. This is one way of doing this. Another way of doing this is this current source can be transformed into a voltage source. So 8 ohms is in parallel with 20 ohms. Then the voltage also you can find out that. So voltage is 160 volts in series with 20 ohms. But both the polarities are different. So in this current and these currents can be flows through the 100 ohms resistor. Means 250 volts is in series with 25. The current flowing through this and this 160 volts in series with 20 ohms, that is current flowing through this is IT and both the currents are flowing through this V. So in this way we can construct this, we can solve this problem in two methods. One way is voltage source is converting into a current source. Another way is current source is converting into a voltage source. So that do this is the homework. So another problem is find the current through 5 ohm resistor using source transformation technique. See here in this problem we are replacing a current source, that is 1 amp is in parallel with 10 ohm resistor that can be replaced with the voltage source. Here by replacing this we can solve this problem. So that by replacing that, how much voltage? There is 10 volts voltage source in series with 10 ohms it becomes, and so there is a 10 ohms already, it is a voltage source with 5 ohms in series. Here there is a 10 ohms is in series with 15 ohms becomes, and there is a 5 ohm resistor is there, terminal impedance. So in this way you can calculate the voltage. Thank you.